Okay, deciding which equations are linear. Um, and one way of deciding whether the equation is linear is to make a graph, and if the graph is a straight line, then the equation is linear. So for this example here, we have the equation y equal 2x plus 1, and we can pick some numbers for x and then compute y. And usually it's best to pick, or it's most convenient to pick small whole numbers or integers. You could pick large numbers or fractions or decimals, but if we pick a few small whole numbers or integers, that's probably enough to give us an idea about whether the equation is linear or not. So I picked -2 for x, -2, -1, 0, 1, and 2, and I'll use these to compute y. So if x is -2, y is going to be 2 times -2 plus 1. 2 times -2 is -4. -4 plus 1 is -3. If x is -1, y is going to be 2 times -1 plus 1. 2 times -1 is -2. -2 plus 1 is -1. If y is 0, x will be 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. If x is 1, y will be 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. If x is 2, y will be 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. Okay, so now we can draw a coordinate system and sketch the graph, plot the points and sketch the graph. So the x scale goes left and right. Positive is to the right, negative is to the left. So we have, I'm not labeling all these points, but you can go 1, 2, 3, 4, 5 going to the right, -1, -2, -3, -4, -5 going to the left, and the y scale is vertical. Positive is up, negative is down. So we have 1, 2, 3, 4, 5 going up, and -1, -2, -3, -4, -5 going down. And then we can plot the points. So the first point has x coordinate -2, y coordinate -3. So we want to go 2 to the left and down 3. And put a little dot there. Next point could be 1 to the left, down 1. And then we have 0 left or right, up 1. That's right on the y axis. 1 to the right, up 3. And 2 to the right, up 5. Okay, and they do appear to be on the same straight line, and we can connect the dots, and it looks like they're on the same straight line. Okay, so that means it is linear. So linear is a yes. And let's see if I get a better pen here. And also, let's compute the slope. Every time we go over 1, we go up 2. So for example, if we go from 0 to 1, we go from 1 to 3. When the x value increases 1, the y value increases 2. If we go from 1 to 2, x value is going up 1, the y value goes from 3 to 5. So the slope is going to be 2. In this form of the equation, this is called the slope-intercept form. It gives you the slope of 2. The 2 is the number next to x. So slope is 2. Okay. Okay. So the next example. We have y equal the quantity x minus 2 squared minus 6. And again, we want to pick some numbers for x and compute y. Usually you want to pick small whole numbers or integers. It's more just for the convenience of it. I mean, we could put fractions or decimals or large numbers in here, but then the computations are harder. So I picked 0, 1, 2, 3, and 4. and replace x by these numbers in the equation. So if x is 0, y is going to be 0 minus 2 squared minus 6. 0 minus 2 is negative 2, so negative 2 squared minus 6. Negative 2 squared, negative 2 times negative 2 is 4. 4 minus 6 is negative 2. If x is 1, we'll have 1 minus 2 squared minus 6. 1 minus 2 is negative 1. Negative 1 squared minus 6. Negative 1 squared, negative times negative is positive. Negative 1 times negative 1 is positive 1. 1 minus 6 is negative 5. X is 2. Y will be 2 minus 2 squared minus 6. 2 minus 2 is 0. That's 0 squared minus 6. 0 squared, 0 times 0 is 0. 0 minus 6 is negative 6. And it's x is 3. 3 minus 2 squared minus 6. 3 minus 2 is 1. 1 squared minus 6. 1 squared is 1 times 1 is 1. 1 minus 6 is negative 5. X is 4. So 4 minus 2 squared minus 6. 4 minus 2 is 2. 2 squared minus 6. 2 times 2 is 4. 4 minus 6 is negative 2. Okay, so then we have some points, and we can plot the points. Okay, so we have x goes left or right, positive is to the right, negative is to the left. We have 1, 2, 3, 4, 5. Y is up and down. The negative is down, positive will be up. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so then we can plot the points. And so we have 0 left to right, down 2. 1 to the right, down 5. 2 to the right, down 6. 3 to the right, down 5. And 4 to the right, down 2. Now these do not appear to be on the same straight line. Let's connect the dots here. By connecting the dots, we get also the fractions and decimals and points in between without having to compute them. Okay, so here's our graph, and it doesn't appear to be a straight line, so it's not linear. That's a no. And the slope varies. If on the at the left side of the graph, it looks like we have negative slope. We're going down as you go from left to right, and then it kind of levels out in the middle part of the graph, and then as you continue to the right, it looks like it has positive slope. The slope is going up, so it goes down and it's kind of level, and then it goes up. So the slope varies. It's not a constant slope, and that's typical of equations that are not linear. Usually the slope is not going to be constant. For a linear equation, the slope will always stay the same. Okay, so next example. Y equals 7, and again we can pick some number for x and compute y. I picked negative 2, negative 1, 0, 1, and 2 for x. Usually you want small integers or whole numbers. So there's no x in this equation, so if x is negative 2, y is going to be 7. If x is negative 1, y is going to be 7. So y is going to be 7 no matter what, because there's no x in the equation. If x is 0, y is 7. If x is 1, y is 7. If x is 2, y is 7. So then we have some points, and we can plot the points. X goes left to right. positive is to the right, negative to the left. 1, 2, 3, 4, 5. 1, -1, -2, -3, -4, -5. Y is up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we can plot the point. So we have 2 to the left, up 7. About right here. 1 to the left, up 7. 0 left to right, up 7. 1 to the right, up 7. 2 to the right, up 7. Okay, so these do appear to be on the straight line. We can connect the dots here. It's going to be, so it is linear. Slope is 0. Yeah, if the line goes up as you go from left to right, you have a positive slope. If it goes down as you go left to right, it has negative slope, but this has slope 0. And this equation can be written in the form y equals 0x plus 7. Usually it's just written y equals 7, but if you want to emphasize that the slope is 0, you can write this as y equals 0x plus 7. And the slope, when the equation is in this form, the slope is going to be the number that's next to x. So the slope is going to be 0. Okay. Okay, so next example. This is y equal square root of x plus 8 plus 3. And again, I picked some numbers for x, and I'll use those to compute y. I picked -8, -7, -4, 1. I just trying to avoid numbers where that are not perfect squares, so I picked these to come out to be perfect squares. But you could pick any number you want, but these are probably the most convenient ones to work with. If x is -8, y will be square root of -8 plus 8 plus 3. -8 plus 8 is 0, so square root of 0 plus 3. And here's where I sort of was looking ahead to see what would be a perfect square. 0 is a perfect square. A square root of 0 is 0. 0 plus 3, which is 3. If x is -7, y is going to be square root of -7 plus 8 plus 3. -7 plus 8 is 1. We have square root of 1 plus 3. Square root of 1 is 1. 1 plus 3 is 4. If x is -4, y will be square root of -4 plus 8 plus 3. -4 plus 8 is 4. Square root of 4 plus 3. Square root of 4 is 2. 2 plus 3 is 5. If x is 1, y will be square root of 1 plus 8 plus 3. 1 plus 8 is 9. Square root of 9 plus 3. Square root of 9 is 3. 3 plus 3 is 6. Okay, so then we can draw a coordinate system and plot the points. See, I want more on the negative side here. Okay, so we have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. 1, 2, 3, 4, 5, 6, 7. Okay, so the x scale is positive going to the right, negative going to the left. Y scale is positive going up, negative going down. And we can plot the points here. First point is 8 to the left, up 3. So go 8 to the left, up 3. and maybe about right here. And then 7 to the left up 4, 7 to the left up 4, maybe about right here. 4 to the left up 5, 4 to the left up 5, about right here. 1 to the right up 6, 1 to the right up 6. Okay, so then let's connect the dots, and that's our graph. And it's not a straight line. You can see that the the slope is starts out pretty steep, but then it kind of levels out a little bit. So it's not a straight line. So it's not linear. And the slope varies. And that's typical of equations that are not linear. The slope is going to vary. You can actually compute the slope. If you take calculus, that's one of the sort of the main topics of calculus, is to compute slopes of equations that are not linear. Okay, so the next example. The equation is x equal -4. So the y does not appear in this equation. So y can be any number we want. I picked the -2, -1, 0, 1, and 2 for y. If y is -2, x is going to be -4, because x is -4 no matter what. If y is -1, x is -4. If y is 0, x is -4. Y is 1, x is -4. If y is 2, x is -4. And then we can draw a coordinate system and plot the points. So x goes positive to the right, negative to the left. 1, 2, 3, 4, 5, -5 there. Y is positive going up, negative going down. 1, 2, 3, 5. -1, -2, -3. Okay, so then we can plot the points. And by the way, I forgot, when you have slope 0, that's a horizontal line. And my example 3 here, I'd like to mention that this is a horizontal line. That's when you have slope 0, that's a horizontal line. This one is actually going to be a vertical line. So this one here, you have the point -4, -2, that's 4 to the left down 2. And then -4, -1, that's 4 to the left down 1. -4, 0, 4 to the left up or down 0. -4, 1, it's 4 to the left up 1. -4, 2, it's 4 to the left up 2. And these are all in the same straight line. You can connect the dots. That's our line. Okay, so it's linear. That's a yes. The slope is actually undefined. The slope tells how steep the line is, but this is kind of infinitely steep. It's not a slanted line where you have either negative or positive slope, or it's not a horizontal line where you have 0 slope. There's a formula for computing the slope. It's slope is it's sometimes called the rise or the run, or the change in y over the change of x. You can write this as y2 minus x1, y2 minus y1 over x2 minus x1. And let's label these points here. Let's say this is x1, y1, x2, y2. We can use whatever points we want, but I'm going to use these points here. x1 is -4, y1 is 1. So it's going to be y2 minus y1. That's 2 minus 1 over negative 4 minus the negative 4. 2 minus 1 is 1. Double negative is positive, so it's negative 4 plus 4. So this can be 1 divided by 0. And 1 divided by 0, no matter what number you put on top, you're going to get the same remainder. If you divide, let's say, 0 into 1, goes 17 times. 17 times 0 is 0, with the remainder 1, right? Or you could say 0 into 1 goes 23 times. 23 times 0 is 0, with the remainder 1. No matter what number you put on top, you're going to get remainder 1. So this is, when that happens, we say the answer is undefined. The slope is undefined. So the slope here is undefined, and this is actually what's called a vertical line. Vertical line goes straight up or down. And the one we had before, where we had slope 0, is a horizontal line. This one's a vertical line. Okay. Okay, so you can tell from there's a way of telling from the equation whether an equation is linear or not. We were using the graph to help us determine whether the equation was linear, but so the a linear equation in variables x and y can be written in the form ax plus by equals c, where a, b, and c are numbers, and a and b are not both 0. So linear equations, thus linear equations have at least one variable, no exponents, no square roots, no xy products, and no variables in the denominator. So 2x minus 3y equals 15. That can be written in the form ax plus by equals c, right? So this is this one's linear. That one's linear. It's this is it can be written in the form 2x plus negative 3 times y is equal to 15. That's ax plus by. Ax plus by is equal to c. So it can be written in that form. That's a linear equation. Even without making the graph, we can see that that's a linear equation. This next equation, 2x squared equals 5x minus 3, is not linear. Okay, that's this one is not linear because it has an exponent here. It can't be written in the form ax plus by equals c. This one has an exponent here, so it's not linear. Okay. The next equation, x equals negative 4, is linear. We don't have any exponents. X is not in the denominator. It can be written in the form of 1x plus 0y equals negative 4. So it can be written in this form, ax plus by equals c, where a would be a is 1, b is 0, c is negative 4. As long as a and b are not both 0, that's a linear equation. This is a vertical line. Okay. 12 minus 3 equals 9 is not a linear equation. There's no letters in it. Linear equation has to have at least one letter in it. So this one, D, is not. Y equals 0. This is a linear equation, right? This is a linear equation. It can be written as 1x, no, 0x rather, 0x plus 1y equals 0. So it's this is A, B, and C. It can be written in the form ax plus by equals c. This is a linear equation. We have y. There's no exponent. There's no letter under a square root, and no letter in the denominator. Actually, I said no square roots, but no letter under, no variable under the square root, and no variable with an exponent. F is not linear. We have x under the square root, so it's not linear. Part G is not linear. We have an xy product, x times y. We can have a number times x or a number times y, but not a variable times a variable. So this is not linear. H is linear. X and y are to the first power, if you bring this negative 2/3 over to the other side, negative 3 is the same as negative 9/3, then plus 2/3 would be 7/3. So you can actually write it in the form. You don't have to put it in this form here, but you just recognize that x and y are to the first power. But if you want to put it in the form, it would be 1y. Well, let's start with x. So it would be negative 7/3. Negative 7/3 x plus 1y equals 7/9. So it's the form. It can be written in the form ax plus by equals c. But you don't really have to need to put it in that form. Just recognize that x and y are to the first power here, and so it's going to be a linear equation. This last one is not, because we have an x in the denominator. The last one is not linear. Yeah. So linear equations have at least one variable. I say no exponents. I mean no exponents with variables in it, or no square roots with variables. You can have an exponent, just a numerical exponent or a numerical square root, but no exponents or square roots with variables, no xy products, no variables in the denominator. Okay, so the ones that the equations that are linear here, part A, 2x minus 3y equal 15. Part C, x equal negative 4. That's a vertical line. This would be a slanted line. Part E, y equals 0. That's a horizontal line. Part H, y minus 3x equal negative 2/3 x plus 7/9. That would be a slanted line. The other ones are not linear. And that concludes this presentation.